All right, this is lesson 16A. There is an opening problem right here. Please go ahead and pause the video now and read that. All right, here are the things to think about in that word problem. Part A, how can Frank use this information to determine whether the new fertilizer was effective? Part B, how significant is Frank's evidence? Is it sufficient to conclude that the fertilizer was effective? Would it be more significant if the sample size, the amount of tomatoes collected, was bigger? Moving on. So we often hear claims about population parameters, such as the population mean, the average, or a population proportion, P. So for example, a manufacturer of an insect repellent might claim that on average their new product is effective for longer than 6 hours. In stats, we call this statistical hypothesis. We can decide whether a stats hypothesis is reasonable or justified using a formal procedure called hypothesis test. So here are the three components that you'll need for hypothesis testing. You're going to formulate a stats hypothesis, you're going to collect data from a sample, and calculate the stats to test our hypothesis, and then make a decision about the population based on what you see in that sample. So, suppose a claim is made on a population mean and has the value of a null hypothesis. We write that as this equation. This statement is to be true unless we have evidence to reject it. So, H sub 0, which we call the null hypothesis, we accept the population mean, so the null hypothesis is a statement with no difference. If H sub 0 is rejected, the null hypothesis is rejected, then we accept that there is a difference between the mean and the mean sub 0. This statement is called the alternative hypothesis. So in this blue box identifies one-tailed and two-tailed alternative hypothesis. So how does that look for our problems below? So, first example, consider the insect repellent example on the previous page. If the manufacturer of the new brand wants evidence that the new product is superior in protection time, the hypothesis would be stated below. The null hypothesis, the mean equals 6. The new product gives the same protection as the old ones. H sub 1, the alternative, is that the mean is greater than 6, that the new product protects for longer than the old one. So for example, a manufacturer of insect repellent might be claimed that on average their new product is effective 6 hours longer. So that's the problem we're working with. So is it equal to the mean, or is it greater than the mean? Example 2. If a competitor wants evidence that the new product has inferior protection time, the hypothesis would be this. The mean equals 6, the new product gives the same protection, or it's less than. The new product, I'm having a hard time writing this here. It's not letting me write it. The new product protects for less than the old one. Example 3. If a market research studying all products on the market wants to show that the new product differs from the old, but is not concerned whether protection time is more or less, the hypothesis would be the mean is equal to 6, or the mean is not equal to 6, meaning that the new product gives a different protection time than the old. So These are the three scenarios. This is called a one-tailed hypothesis, where the mean is greater than the original. H sub 1, it's less than. Or two-tailed, it's not equal to. So in that original problem, here's the original, 6 hours. And this is saying, is the mean greater than 6 hours? Here's the mean, equal to 6 hours. Is it less than 6 hours? And the last one, the two-tailed, here's your mean of 6 hours. Does it not equal 6 hours?